Hello everyone, welcome to Eduxcite classes. My name is Monit, and in today's session we will continue from our previous video, that is A.4.3. In this we will particularly discuss about the Newton's second law, rotational motion. Okay, so if you have not gone to my previous video, I have made a complete playlist for the topic A, space, time and motion for the new syllabus 2025. Okay, so if you have not watched, please check the playlist. The link is given in the description. These are the formulas that are directly taken from your data booklet. You can check. Tau stands for the torque, force times distance from the pivot point or from the point of rotation, and theta is the angle between the force and the distance. I is nothing but the summation of the moment of inertia, that is mr square. So if any other geometry is given to you, you will be given the moment of inertia for that particular shape. And this is another formula, that is nothing but the Newton's second law of rotational motion. Torque equals to I times alpha. Alpha is the angular acceleration. Also, if you remember from the mechanics, this can be written as force times mass times acceleration. So in mass is representing the moment of inertia, acceleration is represented by angular acceleration, and the net force is represented here with torque. So you can analogy the same whatever the formulas that we have discussed earlier. Okay. Now let us move to the first question. You can pause the video. I will give you time to pause and you can solve, and then you can check with me. So pause the video and solve question number 1. Okay. So question number 1 says that there is a block of mass m, this is the block of mass m, is attached to a string that goes over cylindrical pulley as shown in the figure. Now when the block is released, the pulley begins to turn. So this will turn in this direction, this object will move in the downward direction. So the mass of the pulley is capital M and its radius is capital R. We have to find out the acceleration of the block. So we know that the block will go in this direction, there will be a tension developed here. So and also it will be given in the question to you that the moment of inertia of the cylinder is nothing but, you can consider this as half mr square. Okay. So using this moment of inertia for the cylinder, we have to find out the acceleration. Now these type of questions are quite common. So if I want to draw the free body diagram, it will look like this. So one equation I can make in terms of this is mg, that is my driving force, minus resistive force. If you don't know what is driving force, resistive force, I have explained this in the I think A.2 forces and momentum. You can check the video. So this is driving force mg minus t is equals to A. So this is my equation 1. Now if you see, this is also rotating. Now the rotating force is nothing but the tension. If I want to draw a free body diagram for the pulley is exerting a force by the rope, by the tension in this direction. So tension times perpendicular distance. So this is the moment of force which is rotating this pulley. Okay, so the tension times perpendicular, this is the point of rotation. So it is making an angle 90 degree. So tension times the distance r is your torque. So I can make, say, torque is I times alpha, and this is also equals to tension times capital R. So this will be my equation 2. Now I have to find out the acceleration. So for acceleration I have to write down t in terms of this. So also angular acceleration is linear acceleration upon radius. So this you may have learned, linear acceleration is angular acceleration times radius. So using this, if I put everything in the second equation, I will get I as half mr square times alpha is A by R is equals to t times R. Now if you use this, this R and this R gets cancelled, this R and this R gets cancelled. So tension is nothing but ma by 2. So from here you can say tension is ma by 2. Now I put this tension in equation 1. Using equation 1 I can say, and putting t is equals to ma by 2. So this is mg minus m, capital M is, this is the mass of the pulley, times A by 2 is equals to small m times A. So you can use this to find out A. I can further write this as mg is equals to A is small m plus capital M by 2. So you will get the A as mg, small mg upon small m plus capital M by 2. So this will be your answer for your question number 1. Now they may give you any values for the capital M or small m, so you can put up the values and you can get the answer. I will request all my students to put the values always in your last step. Till that you can use your variables. Okay, you can mention the variables in the starting, the beginning of the question, and then at the end you can put up the values. Okay. So here the moment of inertia is given to you as moment of inertia of the ball is 2 by 5 m r square. Okay, you can use this moment of inertia. Now pause the video and solve. Okay. Now if you look here, what is the given is a snooker ball of mass capital M. So this is my ball of mass capital M, or let me use this, and has a radius r. So this has a radius r. It is hit horizontally with a force F at a distance d from the center of mass. Determine the d such that the ball rolls without slipping. Now when the ball rolls without slipping, this point will have zero velocity. Okay, now this ball will move forward, so the net acceleration, if this ball moves with the forward direction, I can say F net, or F simply the force given in the question itself, is equals to mass capital M times acceleration, let us say A. Okay, now this ball is rotating as well, so due to rotation I can say the force times perpendicular distance, so F time d is your I alpha. So F time d is torque is what? Force r sine theta is 90, so sine 90 is 1, and this is also equals to I alpha. So this is what we are equating in majority of the questions. Okay, so this I got two equations, so I can write down this if I want to find out d. So d can be written as I alpha over F. Right, now I have to find out, and F can be further written as I alpha upon capital M into A. Now if you look here, alpha is nothing but A by R. So further d can be written as, and I is 2 by 5 m, so 2 by 5 m r square times A by R upon M into A. So this A and this A and this A gets cancelled, this M and this M gets cancelled, this R and 1 R get cancelled. So the final answer what we get is d is 2 by 5 times of R only. As simple as that. Okay, so I hope you have understood that what we have to do is we have to just equate the Newton's laws of second law of motion, the Newton's second law of rotational motion. So this is what? This is Newton's second law of motion, and this is Newton's second law of rotational motion. Okay, so I just equate using this. One is for the linear motion and one is for the rotating motion. So this way you can solve question number 2. If you have any doubt, just comment below. I will try my level best to discuss with you and clear your doubts. Now this question has been taken from your past year paper. The reason being, in the past year there was an option B, engineering physics. In that there was a part of rotational motion. So what I have tried is I have taken the questions from the optional topic of your previous syllabus. So you can expect questions like this in your final exam for the HL students. Okay, so this is question number 3 for me, and this is question number 7 from your paper November 17. This is an SL paper. Okay, so look at this question. Pause the video and try to solve the A and B as well. Okay, so you can see here the question is given in such a way that it is a rough plane, so definitely friction will act. Whenever the word rough is there, it means the friction will come into picture. It is released so that the hoop gains linear as well as angular acceleration by rolling without slipping down the plane. Now rolling without slipping, again I am saying the point is having zero velocity and all other linear velocity is v, which is equals to omega r. So they are moving. Rolling without slipping is nothing but the velocity is 2 pi r by t, that it cover one complete rotation in a given time period, and the point of contact will be 0. I will discuss this in my coming videos as well in more detail, but as of now you just imagine this point has 0 velocity which is in contact, and this object is moving with a linear velocity v is equals to omega r, and this point is moving with 2 omega r. So each point on the circumference is moving with omega r, and the linear velocity itself is v equals to omega r in the forward direction. Okay, now on the diagram, first part is draw the and label the forces acting on the hoop. So we know that what are the forces acting. One is vertically downward, that is w. W is your, you have to weight, you have to label as well, weight, which is mg. Then there is a normal reaction force, you can say, which is acting perpendicular to the surface. So it will be somewhat like this. This will be r. So this is normal reaction force, and there will be a friction acting in the upward direction. So this is my friction, Fr is my friction force. These are the forces acting. So this will be my diagram for my A part. Now show that the linear acceleration of A of the hoop is given by this equation. Now linear acceleration, let us say this is moving with an acceleration A. So again I will use both the equations for linear as well as Newton's law for the linear as well as for rotation. So you can try like this. Now if I want to make a component, so this is mg, so this will be mg cos theta. So I am writing with a red color pen, so that mg cos theta, and this will be your mg sin theta, which will be balancing out the, sorry, this will be my mistake. So this will be mg sin theta and this will be theta. So this will be mg cos theta. Now if I want to write down the F net equation, Newton's second law of motion, so F net will be driving force, mg sin theta minus friction is equals to ma. Okay, so this will be my first equation 1. And here if you remember, what is the force responsible for the rolling? So the friction is the rolling part, the moment or the torque force. So friction times the distance r is equals to I alpha. So I can say torque is friction times r is equals to I alpha. Torque is equals to I alpha equals to F friction into r. Now I is given to us as, it is given to us as mr square. It is given in the question. The moment of inertia is mr square, and alpha can be written as A by r. So friction can be written as mr square times A by r divided by r. So you can see this and this gets cancelled. So friction is nothing but ma only. So from friction is equals to ma. Now I put this equation in equation 1. So using equation 1, I can simply say mg sin theta minus ma is equals to ma. So the acceleration will be, this will become 2 ma. So mg sin theta divided by 2m. So m and m gets cancelled. So we get the relation A as g sine theta over 2. So this is how we show the equation. I hope it is quite understood. If not, just watch my previous video. What is this equation, how we frame this? This is driving force, the force in the direction of motion. This is resistive force, force in the opposite direction of motion, and this is the net force. Okay. Now pause the video for C, D and E as well. Okay, so that is quite easy. Theta is 20 degrees, so just put up the value. So g sine 20 divided by 2, where g is your 9.8. So if you put it, you will get acceleration. I have already done the calculation. It will be 1.67 meter per second square or 1.7 meter per second square. Okay, so this will be your answer. Now the D part, state the relationship between the force of friction and angle of incline. Now you know that force of friction we have just find out in the previous part, that friction is equals to ma and a is equals to g sine theta by 2e. So friction is nothing but friction is ma and a is g sine theta by 2. So friction and this will be mg sine theta by 2. So this will be the relation of the force of friction and the angle of incline. Okay. Now the E and the last part, the angle of incline is slowly increased from 0. Determine the angle in terms of the coefficient of friction at which the hoop will begin to slip. Now it will begin to slip means it is the limiting friction condition, right? So limiting friction. So what I can say is it will start to slip when your friction will be equals to the driving force, that is mg sine theta. As the theta increases, the weight component in the downward direction will increase and friction will reach to the maximum limiting case. After that, it will start to slip. So friction we already know, it is mg or nu n. So and friction formula is coefficient of friction times n. N is the normal force, and normal force, if you look here, this R is the normal reaction force that will be balanced by the downward force mg cos theta, because vertical forces are balanced. So mg cos theta will be equals to R. So you can say normal reaction force or nu R, you can say. So this will be nu mg cos of theta. Now using this friction and this equation, I can say nu mg cos theta is equals to mg sine theta. Now mg and mg gets cancelled, so you will get friction is mg sine theta by 2. So this is 2. So you will say that this will be 2 nu as tan theta. Sine over cos is tan. So this will be your relation of coefficient of friction with the theta, or theta can be written as tan inverse of 2 times of nu. One or the way, both are correct. So I hope this question is a past year paper question. You get a very good insight how they may ask you the questions that might have the related concept of your Newton's first law, second law, third law and the rotational motion. Specifically, to be very precise, Newton's second law of motion and Newton's second law of rotational motion. F net is equals to ma and torque equals to I alpha, or force times perpendicular distance from the pivot point. Now look at the question number 4. Pause the video and try for part A. Okay. Now if you read out this question, these are the data given away for the flywheel. This is the small axle radius, this is the flywheel radius, and the masses are given to us, mass of the flywheel and mass of the string we have to find out in one of the part, and the moment of inertia is 0.5 mr square. Now this is started from rest. Okay, this mass is connected to an axle by a light string and allowed to fall vertically from rest. The velocity of the falling object is given to us at this time. Calculate the average angular acceleration of the flywheel. So we have to find out alpha. Now how we will find out this? So what we can say is V is equals to what? V is equals to omega R. So omega final will be 1.89 upon R. Now which one is rotating here? This small axle is rotating, because this mass has been connected with this small axle and this is being rotated. So this object which is falling is connected with the small. So we'll take the radius of the smaller one, which is 0.06 in meters. Okay, this will be 0.06 in meters and this will be 0.24 in meters. So once if you calculate this, I have already done the calculation, it will come out to be 31.5 radian per second. Now once we know omega f, now to find out angular acceleration we can use the equation of rotational mechanics, that is omega final is equals to omega initial plus alpha times t. Now this is 0 because it started from rest, and omega f is 31.5 and alpha we have to find out times t is 3.98. So the alpha comes out to be, if you divide 31.5 divided by 3.98, it will come out to be something around 7.91 radian per second square. I have already done the calculation for saving the time. You can do the calculation in your own calculator, and if you have any doubt you can comment below. Okay, so this will be the answer for the A part. Now pause the video for B part. Okay, so torque is equals to what? Torque is equals to I alpha. I is half mass of the flywheel because it is asking for the flywheel. So that is 1.22 times alpha, which is 7.91. So it's very simple. If you do this, sorry, this is half times m into r square also now, and the radius of flywheel is 0.24, so 0.24 square. So when you do this calculation you will get something around 0.278 Newton meter, you can say, or it is 0.3 Newton meter. Okay, so this we have shown. So this is what is the answer for the B part. Now pause the video for C first and second. Okay, now if you look at the tension in this string, so we know that the tension will be developed like this. So this will be the tension, and tension is the force which is rotating the flywheel, right? So I can say tension times the radius r will be the torque, right? And torque we have already calculated. So torque is equals to tension times perpendicular distance is the radius smaller one, and this is 0.278. Take the whole value, don't take the round off. Tension we have to find out, and the radius of the axle will be 0.06. okay, so 0.06. so when you do this calculation you will get something around 4.63 Newton as the answer. I hope it is quite clear. Now the second, I hope you have done this. Determine the mass of the falling object. Now the mass small m we have to find out. Now small m, what we can do is mg minus t is equals to ma, right? Now a we don't know, so what we know is acceleration, angular acceleration we know, so we can easily find out mg minus t we have already know. So mg minus ma is equals to t, so m will be equals to t upon g minus a. Now for a you can say a is alpha times r, Now alpha, we have calculated the angular acceleration of the flywheel is 7.91 times r is 0.24. so this, when you put up in the calculator, it will come something around, this mass is connected with the smaller one, so you have to use the smaller radius, guys. Be very careful. This is falling object and this m is connected with this axle, so the acceleration will be of this small radial axle, so radius will be 0.06. this will come to 0.4746. so t is 4.63 divided by 9.8 minus 0.4746. so the mass will come out to be 0.496 kg or 0.5 kg to the rounding off. So I hope now this is quite clear how we get the mass. If you have any doubt, just comment below. Even you can find out the PDF of this video. The link will be given in the description. You will be redirected to my website where you can find out the worksheet as well as the marking scheme and the PDF whatever I am doing. Now question number 5, this is again from the past year paper. The previous one was also from November 16. Now read out this question. This is a reasoning based question. Pause the video and solve. Okay, so why method 2 is effective? Because the torque is equals to force times perpendicular distance, right? So if you see, force is same in both the cases. Now we have to do, this is the point of rotation, so perpendicular distance, if I want to find out, it will be this much only, and in this case it will be this much only. So force is same, so perpendicular distance is more in this case, so torque generated will be more. So this method 2 is more effective. So you can say the perpendicular torque is equals to force times perpendicular distance, and force is same in both the situation, in both, but the perpendicular distance is more in method 2, therefore it is more effective. That's it, or more having greater higher torque. So more the torque, more will be the paddle will rotate more easily and more efficient will be the way. So I hope I had tried my best to cover the questions related to the Newton's laws of rotational mechanics, that is torque equals to I alpha, and equating that with the linear motion as well. I take some past year paper question so that you will get an idea. So please share this video with your friends and your classmate who is having IBDP Physics HL. And if you want to get enroll with me and want to know about what are the 3 steps to physics success and discuss with me and to get 7 in your IBDP exam, scan this QR code and have a chat with me. Thank you. I hope you have understood everything what we discussed in this class. See you in the next video. Take care. Keep learning. Bye-bye.